Hi and Assalamualaikum. We are from Group F4S1204_5. Today, we are going to present to you guys about analyzing fats in food using gravimetric analysis. Next, let me introduce to you guys to our amazing group members. Let's start with Putri Nur Farisha binti Megat Ghazali. Second, Nur Kamarina binti Razwan. Third, Nur Marsharina binti Zulkafli. Fourth, Nur Syaidatul Adawiyah binti Yusri. And lastly, me, Nur Alia Karina binti Muhammad Mahidin. Moving on to the next slide, we all know that fat plays an important role in the food nutrition and food chemistry areas of study. Fats are frequently referred to as triglycerides since they are predominantly composed of fatty acids and glycerol. Solid triglycerides are referred to as fats, whereas liquid triglycerides are called oils. Lipids, on the other hand, refer to all of the fatty elements found in food that are dissolved in a fat-solubilizing solvent. Scientifically, there are huge numbers of methods that have been created for the analysis of fats in various food products. These techniques rely on how simple it is to extract fat from particular metrics. Whether fat or total lipids are to be removed from the sample also influences the approach used. So next, what is gravimetric analysis? In analytical chemistry, gravimetric analysis is a technique used to calculate an analyzed quantity based on solid mass. For gravimetric analysis, there are four types of it. First, we have volatilization gravimetry, precipitation gravimetry, electrogravimetry, and lastly, thermogravimetry.
Assalamualaikum and hi, my name is Putri Nur Farisha and I will be talking about theory, which the first one is principle. Gravimetric analysis relies on the principle of isolating and weighing a specific compound. The objective is to isolate the lipid fraction from the food matrix and determine its mass. And the second one is procedure, which the first one is sample preparation, extraction of fats, precipitation, filtration, washing and drying, and lastly weighing. The third theory is calculation, which mass of the extracted lipids is calculated by the difference in mass crucible before and after adding the lipid residue. Percentage of fat in the original food sample can be calculated using the formula equal of mass of lipid residue divided by mass of original sample times with 100, where the mass of the original sample is the mass of the portion used for extraction. And the fourth theory is consideration, which the first one is precision and accurate weighing and handling of samples and equipment. And the second one is interference, which contamination during extraction or handling can affect the purity of the extracted fats and lead to inaccurate measurements. And the last one is verification, which the results should be verified through replicate analysis or comparison with alternative methods to ensure accuracy and reliability.
So here are the methodology parts. We have three methods that we use in this experiment or analysis. First one is acid hydrolysis method. Extract fat from the sample and subjected it to the hydrochloric acid and mix ethers. The second one is a base hydrolysis, which is extract the fat from the sample by treating it with the base, which is ammonium hydroxide, and subjected it into mixed ethers. And the third one is acid and base hydrolysis. Extract fat from the sample by treatment with the ammonium hydroxide. After that, the fat is subject to the hydrochloric acids and extracted using mixed ethers. So here I provide the gravimetric procedure pictures. As you can see, there's a few steps to do in this experiment. So I will let you know about the apparatus and chemicals first. Apparatus we use in this experiment is analytical balance, beaker, solvent extractor, condenser, filter paper, desiccator, Buchner funnel, and vacuum filtration. And for the chemicals, we use hydrochloric acid or sulfuric acid. We use sodium hydroxide or potassium hydroxide, and the mixed ether is diethyl ether or petroleum ether. For the first method is acid hydrolysis. The procedure is the hydrochloric acid will break the fatty acids from the glycerides, glycolipids, phospholipid, and sterol ester. Next, acid hydrolysis also breaks the lipid, carbohydrate, bonds, which is assist the hydrolysis of proteins and polysaccharides and disrupt the cell walls. The third one, all of these will mix the lipids available for complete extraction, which are mixed ethers. Then the ether is evaporates and the extracted residue is weak. As you can see, the picture I show on this slide is a acid hydrolysis reactor that used in this experiment, which is acid hydrolysis. Second method is base hydrolysis, which is the ammonium hydroxide weakens the lipid protein bonds in order to disrupt the casein, breaks up fat emulsion and utilize any endogenous acid prior to the extraction, which the mixed ethers. Then a centrifugation step also aids the breaking of emulsions, which are common in daily products, and it aids in separating the ether layer from the aqueous phase. And then the sample are extracted into a mixed ethers. The total fat is calculated gravimetrically after the evaporation and the residue is weak. The pictures I provide is show the apparatus that we use for a base hydrolysis method in this experiment. The third and the last method that we use is acid-base hydrolysis. The procedure is the ammonium hydroxide weakens the lipid-protein bonds, and then the acid will break the lipid-carbohydrate bonds, making the lipid available for complete extraction. And then the sample are extracted into mixed ethers, and total fat is calculated gravimetrically. So the picture I provide is show that how the acid-base hydrolysis set up in this experiment.
Let's move on to the example. First, we have the material here. We choose potato chip as the sample. Okay, so we have analytical balance, salt slag extractor, organic solvent. We use hexane, timber, drying oven, desiccator, beakers or flask. Okay, so for the procedure, we have sample preparation, extraction, solvent removal, drying and weighing, and calculation. So let's start with sample preparation. Firstly, we have to dry the extraction timber in an oven at 105 Celsius for 1 hour. Cool it in desiccator and weigh it accurately. Let's say the timber weighs around 5 grams. Weigh 10 grams of crushed potato chips, record the weight accurately and place the crushed potato chips in the extraction timber. Okay, the second part is extraction. Place the timber containing the potato chips into the salt slag extractor, then add hexane to the salt slag extractor until it reaches the siphon level. Connect the salt slag apparatus to a condenser and a boiling flask containing additional hexane. Heat the hexane to reflux, allowing the solvent vapor to rise, condense and wash over the potato chip sample. Dissolving the fats. The fats-laden solvent will siphon back into the boiling flask. Okay, so continue the extraction process for 6 hours to ensure the complete fat extraction. The third one is solvent removal. After extraction, let the apparatus cool. Carefully remove the timber and transfer the solvent containing the extracted fat to a pre-weighed beaker or flask. Assume the pre-weighed beaker is 50 grams. Evaporate the hexane using a rotary evaporator or by gentle heating the beaker in a fume hood until all the solvent evaporates. So after the solvent removal, we continue to the next step. It is drying and weighing. Place the beaker containing the extracted fat in a drying oven at 105 Celsius for 1 hour to remove any remaining solvent. Cool the beaker in a desiccator at room temperature. Weigh the beaker with the dried fat. Let's say the beaker now weighs 52 grams. So let's move to the last part where the calculation. We have to calculate the mass of extracted fat. Mass of extracted fat equal to mass of beaker with fat minus mass of empty beaker. So the mass of extracted fat that we got is 2 gram. So to calculate the percentage of fat in the potato chip sample, we have to use this formula. 2/10 times 100. So the percentage of fat that we got is 20%.
So, the conclusion is, the gravimetric analysis for determining fat content has proven to be a reliable and accurate method. By utilizing a solvent extraction process followed by evaporation, we were able to precisely measure the fat content in various samples. This method is advantageous due to its straightforward procedure and cost effectiveness requiring minimal specialized equipment. However, it is essential to ensure complete solvent removal to avoid inaccuracy. Compared to more complex techniques like chromatographic methods, the gravimetric method remains highly accessible and efficient for routine analysis, particularly in the food industry. The results obtained in this study align well with expected fat content values, validating the method's effectiveness. Despite its benefits, there are some limitations such as the potential for solvent loss and the sensitivity of the method to sample preparation. Future improvements could focus on optimizing solvent recovery and enhancing automation to increase throughput and consistency. Overall, the gravimetric method remains a valuable tool for fat analysis, providing essential data for quality control and regulatory compliance in various industries. Further research and technological advancement may enhance its application and efficiency. So, you have reached to the end of this video. I hope you guys enjoy this video and also find it really informative. Please don't forget to like and share this video to your nearest friends or family. That's all from us. Thank you. Bye.